Welcome back to Math 068. This is Professor Needing, and we are going to cover Section 4, two-way tables. When we talk about two-way tables, what we're talking about, first of all, is categorical data. We're on page 18 of your student handout. And categorical data starts with a frequency table. And if we go down a little bit here, this is a typical frequency table. Now, above, you should definitely do the reading, and I will go over that with you during lecture. When we talk about a frequency table, we're talking about how many respondents answered to a particular category. So, for instance, you can see that we have 23 people who responded that they do not play a sport, but yet simultaneously they did not take a foreign language. 23. Also, if I look at how many people took a foreign language, I can see that the sum of 14 plus 23, because I have people who played a sport that took a foreign language, and I have people who did not take a sport that still played a foreign language, and I have 37 people who in total took a foreign language. I could look at the same for a column. If I want to talk about just those who do not play a sport, there are 26 people who did not play a sport. 23 of them happen to be taking a foreign language, and 3 of them happen to not be taking a foreign language, but 26 of them did not play a sport. If I'm looking at all of the respondents in the entire two-way table, then I have 50 respondents. It's called a two-way table because it comes in from two different directions, rows and columns. And those are two different categories. If we go down the bottom here, we look at student exercise 1. We have a Canadian longitudinal study which examined whether giving antibiotics in infancy increases the likelihood that a child will become overweight later in life. It said the children were classified as having receiving antibiotics or not during the first year of life, and then being overweight and not by 9 years old. The study included 616 children. Right there is our first piece of information, 616 children, and that's going to be our total of all totals right there, 616. Then they've already given us the data for who's overweight, who's not overweight, who was in antibiotics, and who was not in antibiotics. I'm going to change my color so it stands out a little bit more for you. So we now know that over here, and I got to move this a little bit slightly. How's this? Woo, that kind of goes over. That we're going to take 37. Trying to type here. That we're going to take 37 and we're going to add to it 141. And when we sum those two things, we're going to get 178. For that first value, or that first total of non-antibiotic, we're going to have 178. I hate that that thing is moved over where that thing is. It just bothers me. I'm going to do this on paper if you don't mind. I think it'll be better. I can't type where I want to type. Here we go. So 178 here because of the sum of 37 and 141. 144 and 294 makes 438. So total number of antibiotic cases are 438. The total number of overweight cases are 181, and the total number of non-overweight cases are 435. If I check 438 plus 178, it's the same thing as 181 plus 435. It adds up to be 616. So that's important. So let's go over and look at these questions on the next page, because these are where it really happens. So now it says, calculate the proportion of all children in this study that were given antibiotics during the first year of life. So what's going to be most important is that we identify the population from where this data is coming. And by that, what I mean is that we need to find out that this is a proportion of all children in the study. Okay, so when I'm talking about what's important or what the population is, that's the first thing I'm identifying right there. Okay, is of all children. Well, if I go back to the page before, of all children is 616. It's right here. It's that total value of everybody. So we're going to need to make a proportion or a p-hat value, as you'll come to know it so well, for this specific value? Well, the first thing we have to have is for those who were given antibiotics in the first year of life. So if we go back up here and we look at given antibiotics, that would be the row right here. And we added up this row just 1 second ago. And when we did that row, let me bring it back up for you. And we're going to keep referring back to this piece of paper. This first row, given antibiotics, 438. Of those in the study, 616. So my very first one, my p hat, and this is how it's labeled, p hat, proportion of, the proportion of all children who were given antibiotics in the first year is 438 out of 16, approximately 0.71, because the problem said to round to the nearest 100. Question 2. What's the proportion, again, of all children? The denominator is 16 because of all children. And then that were classified as overweight by 9. So I go back, I look for those who are overweight. The number of overweights are 181, and 181 becomes my numerator. This is who I'm studying. This is out of what population? What is the proportion of those not receiving antibiotics? Okay, well, notice the denominator is not 616. Of those not receiving antibiotics, I go and find those who are not receiving antibiotics. It's 178. From there, I look at the question. The question was overweight. So the people who are overweight are 37 out of 178. My proportional value for C is 0.20. Letter D. What is the proportion of all children classified as overweight that were given antibiotics in the year of life? Okay, well, we know we have children who are overweight and we have ones who were given antibiotics. Okay? So when we go back to that question and we read that question, proportion of all children classified as overweight. So those are the kiddos we go to first. 181. And how many of them were given antibiotics? Well, 144. So 144 out of 181 is approximately 0.80 or 80%. So let's try exercise number 2. And in exercise number 2, we're going to do all the same things, but now you got to kind of pull some of the data out. Now, one of the first things you have to do in this type of problem, if you will, is you may have to fill in some blank organization. And by that, what I mean is that you have to use a little bit of backwards math here, right? So we have a total of 244 for the pregnant row. We know the smokers are 38, so obviously the non-smokers are 244. Take away the 38 is what we would do right here. And I need to switch over to something else. I need to make that go away. Give me 1 second. Clicking the wrong stuff here. I'm just going crazy, right? And let me try and put it in. There we go. So I'm going to take 244, and I'm going to subtract 38. And when I do 244 and I subtract 38 for that value, make sure I got the right number here. 206. 206. So I have 206 non-smokers. Okay, we'll go do this one here. Go do not pregnant. Now remember, not pregnant is a sum of the column. The total in this column is 135. However, we already know that 38 people were smokers, so 138, subtract that value, will leave me with 97. This column or row total over here, it's either 244 plus 434, or it's 135 plus 543. Both of them have to give the same exact answer. And matter of fact, I mean, it's a great idea to check that to make sure you're getting 678. Word of caution right here. If you get one of these numbers wrong in here out of haste or reading your calculator incorrectly or whatever it happens to be, then you're going to have a problem because every question you answer is going to be incorrect when it comes down to the second set of questions, which are the most important questions. So here, I'm going to answer these, and I think I'm going to go back to my writing so I can see it a little bit clearer. And I'll do these with you, and then you'll be on to exercise 3 for yourself. So find the proportion, express it as the nearest thousands, 3 positions on this one. The proportion of women who successfully became pregnant. Okay, so we have to find of women who successfully became pregnant. So I have to go over here, of women who successfully became pregnant, right here. Okay, so there's my 244. How many of them are smokers? Okay, and I just keep flipping back and forth, but I have to. There's 38. So I have 38 out of 244, so 0.516. What is the proportion of smokers who are pregnant? Okay, proportion of smokers. Of smokers are 135. Those who are pregnant, 135. Those who are pregnant are 38. 0.281. What is the proportion of pregnant women? Okay, well, of pregnant women, we already saw that up here was 244, who are non-smokers. 206 of the ladies who are pregnant are 206 out of 244 for 84.4. And remember, these would all be registered as p-hat values of some type. These are proportions. We are taking frequencies, 38 and 244. This is the frequency out of 244, which creates the proportion. What is the proportion of women who successfully became pregnant? Okay, well, now we're looking at all, because it says of women. Of women, everybody in here is a woman, 678. 244 of them successfully became pregnant, approximately 36%. What's the proportion of non-smoking women who became pregnant? So now we're focusing just simply on non-smoking women. They had a percentile of 379. Non-smoking women successfully became pregnant. Again, watch your total, watch the of. Look for the of key. See, every place I started to underline started in the word of. Exercise 3 is all on you, and this will be part of your upload. And don't forget about the questions that follow up on that particular one. Fill in the table completely, double check yourself, make sure your total is correct, do all your answers appropriately, type it, write it, whatever you're going to do. And this will be the first part of your second upload. See you back when we come back in for Stat Key Basics, Chapter 5. Always an interesting chapter.